All right, our next guest works both on Bitcoin and on Lightning. He is Antoine Riard. Welcome.
Yeah, hi everyone. Thanks for having me. Just before to start, if you want to take photo of my slides, that's cool, but don't take photo of me. I'm thinking you really well. So today, Schnorr-Taproot'ed Lightning. That's a really exciting topics. Just a quick start, Lightning architecture, for the one who are not familiar with it. You have basically the blockchain on the, as an underlying layer. On top of it, you are going to build like a channel, and you will have HTLC, and people are going to send onions to you, and if you want to get paid, you're going to send an invoice to the sender. So, what we should designing Lightning for? You know, when you are doing a lot of Lightning design spec, we are pouring a lot of brain power into it, and everyone has like different view of what Lightning should be. Is Lightning should be, you know, a fast payment transaction system? Is Lightning should be optimized for microtransaction? Is Lightning really cool because you get instant finality of your transactions? Is privacy the reason we are doing Lightning? Because Lightning may have better privacy properties. And when we are talking about privacy for Lightning, it will be better to have the privacy of the base layer in mind. You know, on the base layer, you are going to broadcast transaction. This transaction, there is an amount, it's not encrypted, and there is address that are not encrypted anymore, they are not encrypted, and you are going to link input and output in the UTXO graph. So privacy for the base layer is not that great today. And you know, Lightning may be a way to solve the privacy, but still, you know, on Lightning there is this payment path. There is like nodes. Lightning nodes have public key, have pub keys tied to them, and that's an identity vector. And HTLC, you may reuse a hash, or you may, yeah, there is a lot of different privacy vectors. So privacy is, I think, really important, and if you want a censorship-resistant money, and the censorship-resistant money is something like everyone cares about in Bitcoin, I guess. Yeah, if you don't have privacy, I can still bribe you, I can still blackmail you, because I know how you are using this tech. And so that's a huge vector attack. There is this awesome paper by Philippe Rogueray, who is a famous cryptographer, and I invite everyone to read it. Yeah, so privacy. You can see like Schnorr and Taproot as privacy boost, as the reason to modify the consensus-based layer, and modifying the consensus-based layer is really a lot of work. There is a lot of people involved. Yeah, that's a lot of work, so it has to get really good motivation for doing this. So Schnorr is just a replacement for ECDSA. Originally, I think Satoshi didn't get Schnorr into Bitcoin because there was some kind of patent issues, but Schnorr is really awesome because there is linearity of every one of its components of the verification equation of Schnorr. Linearity means it's easy to sum up components. It's easy to sum up signature. It's easy to sum up pub keys. It's easy to sum nonces between different parties. And the other big improvement, the other big new consensus upgrade is at least the proposal, because right now nothing has been adopted by the network, is Taproot. Taproot is the idea of building a Merkle tree, and every leaf of the Merkle tree is going to be a script, and you are going to commit the roots of the Merkle tree inside the pub key of the transaction.